Another problem we'll be trying for U-substitution is a definite integral problem. So integral from 1 to 0 of x squared times e of x cubed times d of x. So again, like last time, we have to choose our u, and we'll choose that x cubed is the best fit for being u. Du, once we find the derivative, is just 3x squared, and we do the same process as last time. So we have to solve now for x squared times d of x. So if we put du equal to 3x squared times d of x and divide by 3, we'll get x squared of d of x equals 1/3 times du. The original limits are in terms of x, so x equals 0 and x equals 1. So we need to find the u values based on that. So when x equals 0, u equals 0 cubed, which is just 0. And when x equals 1, u equals 1 cubed, which is just 1. So our limits, as before, or our u values are just u to 1. Now we can just substitute u in x squared d of x into the new integral. So the integral becomes integral approaching 1 to 0 times e to the u times 1/3 du. Or bringing the integral to the outside, 1/3 times the integral from 1 to 0 times e to the u times du. Now we integrate with respect to u, as last time. The integral of e to the u is just e to the u. So 1/3 times e to the u with the integral 1 to 0. Now our last step before we find our final answer is to apply the fundamental theorem of calculus. So 1/3 times e to the 1 minus e to the 0, bringing in that integral. And we have to remember that e to the u is just equal to 1, e to the 0 is just equal to 1. So when we simplify that, we have our final answer being 1/3 times e minus 1 as our definite integral.